Okay, well, we then experiment turning off the mains and just use the swing arms, see if it gets the main light out of the reflecting of the camera. Maybe swing the swing arms forward a little bit.
Okay.
We still moving, Nev?
No, it's not helping. So you can go back to your standard config.
1 minute left in the move. Okay.
And pilots, if we can keep our eyes peeled for another one of those octocorals that we tried to sample right before the fire drill, that would be great. There might be some of them coming up on the right here.
Okay, yeah, that's what I was wondering. Watch lead.
So I'm looking at
Thanks
you at
very
40
much.
degrees, so I wouldn't get too much further ahead, but I would
Copy
kind of
that.
scan around this area while the ship catches up.
Yeah, I think I could set up for one of these watch lead if that looks like could do a partial real
I
quick.
believe so, yeah. Looks good to me. Does that
Yeah,
look
just
right
okay.
to you,
Equal.
Scott, for a representative of...
Full wide
Okay.
video.
So I'll bring everything normal again. Okay.
Yeah, if we
Okay,
could get
so
a
I
bit of
will
a
come
close-up,
at
that
it
would help, so we can just make sure that it's the right polyp structure.
from over here.
Okay, yeah, we can, once we sit down a little
Copy,
bit, we can
move complete.
take a closer look and get lasers on it.
And if we find one maybe attached to a rock, that would serve a double purpose. I do mean like that one to the bottom right. We might have passed over one too. That would suffice, but let's see what we have here first.
Get your lights on in a second. Roll up. There we go. All right, back to normal.
The bottom left looks good also.
Okay.
Yeah, I meant bottom left actually. I think I said bottom right. But
Okay, I can
yeah,
go
that
for
would be
one.
good. And I just pick up the rock.
Okay, just a reminder, pilot, port inner is the only one that's full right now.
Copy that. So should we go port outer or try and go for the starboard?
What's in the port? Well, it's up to you, Andy. Do you want to go for the port, or do you want to do the starboard?
Don't have anything about floaters or anything.
No floaters. Okay.
No notes or
You want to
anything.
just go for the port then?
Yeah, I
Let's do
think
it.
so.
Let's do it.
Okay.
All right.
So we're setting up to sample this octocoral. This is what we were attempting to do before the fire drill. And we are hoping that this rock, the sample that's right in the lasers right now, we're hoping that the rock is loose, and then we can just take the rock as well as the sample and get a geology and biology pair.
Yeah,
Cheryl, so I didn't hear which one we're collecting, but
Okay, so
that bigger one to the
I'll check
left of
the
laser
grip force
caught my
once
eye,
we
unless
enable
you're trying to
hydraulics,
pick one
correct?
up on a rock.
Yeah.
Yeah, we're actually trying to pick one up on a rock.
Okay, hydraulics coming on.
Okay, that's great. Thanks.
Since we have both
Indexed
rock
out.
boxes
Grip
full
force
already.
is 4. I think that's a good
And
one
Leslie
for this
really
rock.
wanted a
Co-pilot?
Sure.
a rock
Okay.
from the base and the top. So this
Alright.
might be our chance to get one from the top.
Did we want to get a close
And also,
up to
this is a
before
very
we
different rock
pick it?
from what we've seen.
Sure.
We'll take a closer look at it here. It's
Looking
almost
down.
nodule-like.
Get a bonus anemone.
So co-pilot, I was thinking about coming in kind of a little bit low, come underneath it, grab it like that, and then swing around and put it into the box.
So
What do you think?
I want to confirm the they just want you to cut the coral, or are they hoping to
No, they're hoping me. They
the
want
whole rock?
Yeah.
So let's nudge the rock.
Okay.
Make sure it's loose with the jaws closed.
Copy.
And then we'll get an idea of the size.
Okay.
See if there's anything hidden below, like the sediment.
Copy.
And then let's go from there.
Okay.
It's pull wide, less the skids.
I got to keep it so you can see the arm for now. I'll tilt down when he's down lower. And you can see all of his joints. Let's just give it a little nudge.
Yeah, it looks like it's loose. And
Okay.
It's just that size.
Yeah, looks reasonable. So, just want you to go ahead and index out for a second.
Okay. Index out.
So I think you're basically just picking up the rock and the coral.
Yep.
And so you're going to go for the port outer box, right?
Yep.
So which means like when your arm is over the box, you're going to have your shoulder down a bit. You're going to have your elbow extended a bit. You basically want to keep your wrist as straight as you can.
Okay.
And then just adjust the wrist pitch a little bit to make sure as you bring the shoulder down, you're going to shoulder down into the box, right? And
Yep.
you want to keep just adjust your wrist pitch to keep your wrist as vertical as possible. And then you just want to set it down. So what I would do is just pick it up from the top.
Okay. Try and get as vertical an angle as I can.
Yeah.
Which it looks like I can get a pretty vertical one.
Yep. And then you can just pick it up, keep it upright the whole time, and then bring it right over to the box and set it down.
Copy that.
So you can try that. I'll follow you over. Okay. I'm going to go ahead and extend the drawer if you're ready.
Copy that.
It's a full extension.
So I'm going port outer.
Port outer, yeah. So index out for a second.
Okay, indexing out.
You see in the minute cam how your wrist pitch is kind of angled forward?
Yep.
So just, or I guess, yeah, angle it to the left a bit and straighten it out.
Copy.
There you go. Nice. Oh, and bring it over, shoulder to the left a bit.
Okay.
Okay, arm is clear. Retracting drawer.
Copy that.
All right, nice job.
And we have our plumarella sample and a rock sample.
I'll bring the camera over for
That
the
is
stow.
Thank you.
Sample number 4, bio, for those of you recording or
Look how your
annotating.
wrist is.
Yeah.
our second attempt at 04, which got away from us. So this is still being considered as sample number 4. So these rocks you're seeing are certainly influenced by precipitation of mineral matter on some pre-existing rock or pebble or even a shell. If they are true nodules, then that'd be pretty interesting to find here. But
honestly, once you
on the Charleston Bump, west of this area, we find manganese phosphorite rocks, which are so hard when they are forming pavements. They're so hard that even coring devices can't get through them. So they're extremely resistant to erosion.
Both of those.
The fact that these are all broken up into smaller pieces makes me think that they are not that, but it certainly looks as though chemical precipitation from the seawater has occurred here, making these rocks very black.
HD2.
So when we bring it up to the lab, we'll see how rock-like it is. If it pings with a hammer, it's probably some sort of full-blown precipitate, other than, as opposed to being sediment that just has a coating of this material.
Start coming up here.
But it does look different from the rocks we've seen that have this crust on them.
Minis back to you. Ship is stopped and all settled out, so
copy that.
Move at your own pace, and we'll put another ship move in when you're ready.
This is abandoned ship drill, All hands stand by the abandoned ship. Report to your abandoned ship station with PSD emergencies and assigned equipment. All hands report to your abandoned ship station.
This must be drill day aboard the Okeanos Explorer. We don't want to alarm our listeners. You're hearing bells here and there.
Sure.
And we actually did have a little worry earlier. We misunderstood, but it was a drill. So Scott Harris from the Geology Department of College of Charleston, my colleague, he's much more tuned into the stratigraphy and the rocks in this area. The surface and the cobbles look a lot like what we would call a phosphate lag. These types of lag deposits are common at the base of the neogene deposits in the low country inshore. And the low country is where we're from, and the neogene is a time period. So that's that's interesting. They are cobbles. Certainly that's a size category that we use. And the phosphate, where we live in Charleston, there is a formation called the Ashley phosphate. And offshore is the Charleston Bump, which has phosphate-rich pavements and nodules. And phosphate is an indicator of high productivity. It's one of the nutrients in the water column. And so when you see deposits of this on the sea floor in any form, it's an indicator that there has been a lot of productivity and that the ion of phosphate, the phosphate ion, has precipitated out of solution and formed molecule by molecule on some surface. And Charleston Bump, it formed on the sediment pavement and formed a very, very erosion-resistant layer that still exists at the surface. It has enough current there to keep it swept clean, and we did several submersible dives in that area. Here, instead, it's formed these cobbles,
pretty far out into that corner,
which are scattered across the area.
Towards Sirius, and then float backward relative to D2.
Copy.
Tilting up, we're at 40 degrees. Okay, you're gonna have to punch it so you're still drifting that way. You have to fight against the current a bit.
So I'm kind of To me, it feels like I'm coming back into the center of the frame. Do you mean drifting to D2 starboard?
Towards Sirius, so come to port, D2 port, and
Okay.
that'll bring you closer to Sirius. So right now you're far ahead of Sirius.
And Chuck Messing notes that the Miami Terrace limestone is covered with phosphoritic crust, and asks if anyone knows how far north or east this kind of deposit extends. And Chuck, I was hoping to find something. I had asked Jason Chater earlier, just back and forth text, if he expected to see any more of the phosphorites out here as pavement. That's what I'm particularly interested in finding. So I can't answer that other than we're seeing these cobbles here. And Andrea Quattrini asks, are these the kinds of geologic structures that would be of interest to those mining the seafloor?
I was wondering that same thing.
Mm-hmm. Well, certainly if they are manganese rich. Sorry, there's a...
So we're 114 nautical miles off of Cape Fear, North Carolina right now.
Okay. So kind of stay cheated a little bit to...
Yep, you can keep facing this direction and then just kind of saddle along, kind of, try to stay where you're at in terms of where the right side of my screen.
So an octopus upper left.
Straddle along to starboard. And then if you see something up ahead, you have the tether to...
Octopus straight above lasers.
Straight above lasers. Oh, okay, I see it. I'm going for it.
So I suppose this area would be of interest to mining if it were economically feasible and if this type of resource did not exist in a economically possible area. And as with places in the low country, there is phosphate mining going on.
So that's just more affordable because it's easier to get to, right?
Well, I would assume that. I'm hoping that, again, Scott Harris will give us some input. He's more familiar. It does look like an octopus. So while we're looking at the octopus, maybe Jason Chater or Scott Harris can chime in to the chat room or even talk to us.
And that was Roland Barrett who saw that octopus.
Okay, come on in video.
He's trying to hide. Roland Barrett, sorry.
Nolan Barrett. There's a Nolan Barrett and a Roland Bryan.
Right, I was talking about Roland.
Okay, I thought you said Nolan.
I probably did because I was looking at the chat earlier. You can see some little cup corals. I've been noticing those. I'm sure no one's looking at those when there's an octopus. There are some. Wow, that's great.
It looks very peaceful. Is it Octopus Friday? We're past Cephalopod Week. We must be by now. I think last week was Cephalopod Week.
Yep.
Let's go to his eye.
Hopefully our colleague Stephanie Bush is in the area because she is a
you want to take it?
big fan of cephalopods.
And she might be doing the abandoned ship drill right now.
Okay, I'm going to center.
I love how his tentacle on the left, you can see several coils of the tentacle.
Okay, let's rotate left slightly.
Yeah, that's what I'm working on.
So Jason Chater does think that these are manganese nodules. So yes, if those are, they would be of great interest to mining.
That was the left side. Yep, the left coil. So it's showing a single row of suckers.
I don't see Mike Vecchione on the line today either, and he would be another cephalopod expert at the Smithsonian that could help us out with this ID.
The one thing I've learned from our cephalopod experts is they're interested in knowing how many rows of suckers it helps to determine a portion of the species.
Okay, so it looks like we
Video's
have
clear.
one
Copy
row
that.
of suckers
Is
on
that full wide?
No, it isn't.
the arms. That might help somebody identify this eventually.
Go ahead,
Looks
Rich.
like we got a little time, but
Video's clear.
copy. I think science is clear as well.
Stand by. Thank you, though.
And Jason Shader of the USGS
Yeah. Should we
says
put
that
in
these
like a-
manganese nodules are well
30
known for
meters,
this
Andy?
portion of the Blake
Sounds good
Plateau.
to me.
Okay.
Let's do it.
Bridge, we're ready.
It's our first encounter with them, so they are not as they're not found in all the environments, that's for certain.
It's also our first encounter with Lophelia there, I think. Just to the right
You want
of...
to take a quick zoom, or
Yeah, if we... Well,
Good
maybe
copy.
we're going by too fast.
I think we might have seen one when you were at lunch.
Okay.
Oh, sorry, I was rotating you there. Co-pilot.
Copy, Bridge. Move initiated.
Okay, looks like
So I've got,
reasonably far in front.
yep, I got 30 meters coming to you.
Copy.
Big eel coming at you upper left.
Yeah, what is it?
There's an interesting organism.
What is that?
Okay,
It
I'm
is a
trying to
siphonophore.
find what bit with
It's
it.
such a
Wow.
dark color.
So the current's going to take you real fast.
Yeah,
Wow.
wanted to get a little altitude so it could pass beneath me.
Yep, so go hard to port
Hard to port.
as the current's pushing you off my screen.
Okay.
So if you just caught that siphonophore, those are also in the phylum Cnidaria, such as the corals that we've been looking at. But they're in the class Hydrozoa. And there are at least 188 species known. And
go
as you
ahead.
could probably tell, they're colonial organisms that have specialized zooids. Oh wow, and here's a really big parasite on this eel. Might have one on each
It's
side.
like a copepod parasite, and I imagine the two long tail-like things are egg cases.
Yeah. Gosh, that poor guy, he has one on each side.
Okay.
Got you at 40 degrees, Andy. So
Copy.
you're out pretty far ahead,
Okay.
and you're kind of tail into the current right now.
Yep.
I think that might be the largest
I don't think it's
parasite
as
I've
bad
seen on a
anymore.
fish so
It's
far.
not as bad.
No.
Okay, that's good. So why don't you come hard to port?
Yep.
Get closer to Sirius.
And Jason
Coming right
Chater
now.
also said that these are the type of nodules of interest for deep sea mining, although the mineral compositions of them vary from place to place. So these may not be of economic importance. So the sample we collected, hopefully someone will analyze that and give us an answer to the mineability of these nodules.
Whether it's economically worthwhile.
I wouldn't be surprised to see large amounts of iron and phosphate in them as well, just based on other rocks that are west of here. And since we're still in the influence of the Gulf Stream, those ions would likely still be prevalent in the seawaters through time. The seawater
so it
through
looks
time.
like a pretty good setup, co-pilot.
Yeah, I agree. This looks great. I'm down at 45.
Copy.
Are the under vehicle lights on right now?
Yes.
Wow.
Yes, they are.
It is so thick.
It's very foggy. Yeah.
Okay, about 5 meters left on that move.
Copy.
Copy.
We'll just go ahead and prep another one. Keep us
There's
moving.
some growth under that rock
Copy
to
that.
the left.
Another 30 meters.
Rock
Sure.
to the left.
Copy.
They just snap it to show it to science.
This big one. It's
Yeah.
coming into center.
Yeah.
Yeah, sure. Wait till it's centered up and then you could go in. Okay, go for it, video.
I guess those growths were squat lobsters.
Lots of squat lobsters on this rock.
Copy, bridge. After this one, can you repeat the same
Video's
move?
clear.
Range
Copy that.
30 meters,
Okay,
bearing
full line.
270, speed 0.2. Good, copy.
I bet we'd see a lot of serpulid worms that live underneath these rocks. It's a nice solid substrate, and they tend to rest on the surface and make great habitat for other organisms that like to hide beneath.
Let's see what the white object is. Lower center.
Copy. Here we got time. I think I'll just sit down and we could do a quick.
Okay.
And Andrea Quattrini and Amanda Demopoulos wrote a paper about ectoparasite observations on fishes in the northeast U.S. canyons area,
go on
so
in
up
video.
north of where we are, probably mid-Atlantic and New England. And they found that copepods were frequently seen on Synaphobranchidioles.
Up. There we
So
go. I think I got
closer
that
look at
now.
a cup coral. You can see it's actually attached to one of these nodules, so it's not sitting in the sediment. And this is what I would have expected. And I'm not sure of the species. I'm not sure that one's even alive. Either, if it is, it's very retracted.
Video's clear.
Copy that. All right, let's go full wide.
This location is in an area where the Gulf Stream switches its course on a daily or certainly weekly basis, so I wonder if that's what's allowing these sediments to remain at all in place here. Because right now the current's pretty strong, but when we first started our mission, the Gulf Stream axis was west of here, I believe, and so this would have been lower current at that time. So I'm wondering if just that back and forth sort of meandering of the axis isn't providing a strong enough current
Two
all the
different
time
kinds
to
of
keep
fish.
this area swept clean. But there's enough current to keep some organisms
You can go partial
happy.
if you can. Looks like they're kind of getting a little too close.
Yeah, you just
Here,
go
I'll
on to
come
the
in this
second
guy.
one.
Yep, coming around.
So that cutthroat eel appears to be free of parasites, at least any parasites that are as large as those copepods that
Clear.
we just saw.
Okay, full wide.
Yeah, definitely see you're not having to use your thrusters quite as
No,
vigorously.
I think it's a lot lighter.
Oh, did you mark where you think the top of the steep slope is, Fernando, on high pack? The top of the cliff or top of the hill?
No, I did not mark it.
Okay. Usually we'll want to mark that
Back
kind
to
of
the
stuff, just so we know.
parasitic copepods. Andrea writes that the male copepods often parasitize the females so that they can ensure reproduction, and that there are several different copepod species that infect the synaphid-branched cutthroat eels.
Meters. 235 meters.
That is actually some serious layback.
Are we moving right now, Nav?
We are.
Okay.
We've got more octocorals ahead. So these are much larger rocks than we've been seeing.
Yeah, we have about 9 meters left on that one.
Copy.
So if you want to take a look at stream 3, we're going to put up the high pack, and that is a bathymetric map that has the position of both of the ROVs, the D2 as well as Sirius, and the ship. And you will see that the ship is 200 meters away from the ROV right now. So
I mean, it's still fine, but
and you can see on that screen how close the contours are.
Yeah, you could come port on D2 as well while you do that.
We have several of our geologists discussing on the chat room about manganese nodule stories and how they learned of them. I won't read them all. But,
actually.
Oh, did we?
Scott Harris learned about them long ago from what turned out to be an expedition that was a cover-up expedition, so it actually wasn't true. Some of you old-timers like myself may have known of that. The Glomar Explorer was supposedly sampling manganese nodules in the Pacific, but it was just a cover-up to while that same ship searched for a Soviet sub that had sunk. It's a great disappointment to the geologists who were hoping to find more about manganese nodules. Jason Chater has a bag of nodules dredged from the Blake Plateau in 1983. He said they're lying around his office somewhere. I find it hard to misplace a bag of manganese nodules, Jason, but I haven't seen your office.
You must have a lot of stubbed toes.
Yeah.
You can just watch them for a moment.
You could sell them and retire early, perhaps.
Okay, you can go in video.
Oh, we've got another tiny fish here.
down, 55 degrees.
Copy.
That fish looks very attached to that particular nodule. And maybe a gastropod shell in the background. Yep, the fish is going to swim over to it now. Gosh, it's a beautiful video of this fish.
Pulling out wide.
Okay, full wide.
Nice job on it.
Thank you.
Full wide. Pushing
Copy.
past the skids.
Copy. Okay, I'll push a little to starboard.
65 degrees. This is looking good.
If you're unfamiliar with manganese nodules, they're really interesting because they precipitate out of seawater molecule by molecule, and they typically start to grow on some pre-existing shell, rock, whatever exists in the area, and form very, very thin layers that if you were to cut one of these right down the middle, you would see concentric rings very similar to a tree growth, but these are grown in molecular layers instead of one per year. It's hard to age date them, but certainly they take a very long time to grow.
Okay, co-pilot, I'm starting to get a little bit more out in front.
Okay, tilt up. Tilt to 55.
And along mid-ocean ridges, often the flanks of the ridges, they are found in quantities, and those are very much economically mineable because of their compositions. But not easy to get to.
Got another fish or something to left of where lasers would be.
Oh yeah, there's another fish. And the one we were just looking at might be a juvenile Limonema.
Down.
That's
Actually, I'm not sure
what Andrew
that is.
Quattrini was estimating.
Sponge on rock.
Oh, it's a sponge. Or maybe a bryozoan.
Oops, sorry.
Looks like more of those colonial tunicates that we collected earlier in the expedition. And that's the whitish organism with white spots below the purple sponge.
Okay.
Okay, let's just keep it moving. You could do, you want to just do 40 meters, Andy?
Sure.
Got a good pace going right now.
Video's clear.
Okay. Full wide then, video. He's kind of bumping around a little bit there.
It's another one of the Plumarella type octocorals, the big white one, upper right. We're now at 892 meters. Another nice octocoral or
So
two.
fatter fish on the sediment forward.
Forward of the
Underneath
lasers.
that, underneath that top eel. Top eel just passed across it.
Take a quick look at these octocorals, and there might be a fish. I think it's
Still
close
don't see
to
the
a
fish video.
It's off in the distance now. It's
Oh, okay.
Tilting down to 65.
Copy. We'll take a quick zoom on the octocoral, and then we'll get going.
Yeah, his tail's still wiggling in the upper corner.
You can still see him video?
Yeah. I'll get him after this coral if you have time.
Okay.
Sediment's kicked up again.
Tilting down. Looking at you 80 degrees.
Okay. All right, watch lead. Is that a
let this sit for a
comment?
bit. You're not in a rush, Andy.
Okay.
That's a very nice view. Thank you.
Yep.
Video's clear.
All right, full wide then video. And I'll pick up and start moving to starboard.
No rush.
Have a lot of eels patrolling this area.
So straight ahead where you're at now would be where the next fish was.
Okay.
See him. It's now right above your lasers.
Still don't see him. Am I passing over top of him
Right
now?
now your laser's immediately to its left.
Ah, I see it now. Thanks.
Les Watling was asking whether there's been any comprehensive studies that looks at the critters that live in these manganese nodules, and I don't know of one. I bet you that if you could take some quantitative samples, it would be quite interesting.
Maybe you could borrow Jason Chater's bag of manganese nodules on his floor and see
so you can get a profile.
if there's anything still living on them or clinging to them.
I hope not. They probably wouldn't smell too good by now.
All right, we'll sit down
Or
here.
maybe that smell is long gone if they were collected in
Probably
1983.
flying at him.
So this is a larger type of rat tail, is it
Okay,
not?
you can go in video.
Laser's clear. Okay, video's clear.
Okay, full wide. Okay, I'll push to starboard, co-pilot.
All right.
Go ahead, watch one. Absolutely.
That's something off to your right.
Okay.
Or something.
Yep, I'm swinging around to it.
Looks like another glass sponge on this larger rock.
It's like a visor. Several of those shrimp. Several shrimp in front of it.
Long zoom.
Yeah, we could go in. We have time, right, Nav?
Yes, we're not moving. We haven't moved in about 10 minutes.
No, I mean time to...
Oh, yeah.
Okay, full wide video. I'll just sit down real quick then. Okay, come on the video. Oh, we got some shrimp.
And Jason commented that the manganese nodules change morphology on the Blake Plateau from nodular, which is what we're seeing here, to tabular forms as you go east to west. And those tabular forms are what we see as the platform kind of rocks farther east, or farther west, excuse me. And at least that's what folks have found based on the relatively limited investigations into them. And he says this will add a new data point, which is great. We need more data points for that type of study, and there's a lot of variation in the morphology here. And yeah, we've seen some very large
Video's clear.
Okay.
dinner plate in diameter size
There's a white object forward.
pieces.
I was wondering what that
I think
is.
what we're looking at here is about that size.
Push out a little bit.
And then sort of dominated by the smaller nodules.
Looks like an egg.
And we're looking into getting a sediment collection with some of these cup corals, and we might be able to scoop up a few more of the small nodules. We did get a sample of the rock earlier with a plumarella coral on it.
It looked like that larger shrimp that we were just looking at had eggs underneath her abdomen, holding them with her pleopods.
Interesting boundary here.
Yeah.
Wow. And more nodules.
We just took a step up into younger geologic time.
Right here, as a target.
The staircase of geologic time.
Field of nodules.
Nodule boundary or something. Yeah. Field of nodules. Yeah.
All right.
Some kind of descriptor.
There's a few more cup corals, and
Should we maybe sit down here? There are a couple right in the front with a...
yeah.
Yeah, pilot, just coming into the center of the bottom of the screen. Might be a good scoop sample. We could get the sediment, the cup corals, and a nodule.
Copy that watch lead.
And we're currently at a depth of 890 meters. We started at about 1,100. Is that what we ended up being when we went? That was the projected depth, but I
don't think we quite got there.
Okay,
I think
so
it
maybe
was 10:30-ish.
Yeah, I should have written it down.
Watch lead. Both of our port bio boxes are full, and using the scoop to go into the starboard box is not something that we want to attempt right now.
Okay, roger that. Thank you.
Go ahead, watch lead. Yeah, getting the scoop into the starboard boxes is kind of a contortion act with the arm. Copy that, Watchley.
Tilting up.
Oh, here's our first Bathy Pathies that we've seen in a while. And Scott looked up in Seascribe, and we actually were at 987.7 meters. 989.7 meters, sorry, at depth when we reached the bottom. So we'd gone about 100 meters, a little over that. A vertical relief.
It looks like we have more to climb if we finish out this dive. That's more than even what we projected looking at the multi-beam.
Right. And Amy Bowman had us at 1,005 meters, the deepest today.
Right, maybe the deepest, but the beginning of the wall that we saw
30 meters.
might have been shallower, so that might be the difference in the estimates. I don't know. I didn't write it down, sadly. Actually, I did. I wrote that the base of the vertical section of the wall is what I wrote down at 940 meters, but we had seen plenty of the outcropping rock below that. We're still hoping to find an area that is rich with the stony corals, either Lophelia or Madrepora.
We've seen Selenosmilia, and I think we did see a few colonies of Lophelia, but they were very small, especially compared to what we saw yesterday.
Anything would be small compared to yesterday.
Yeah.
That was pretty lush. But with all of the past 3 dives, the greatest densities of these Lophelia stony corals was found at the tops of the features, highest up into the Gulf Stream. So as we rise up to the top of this steep scarp that we are calling the Richardson Scarp, we're hoping to find some of those communities of organisms at the top. We had predicted that we'd be in the lee of the Gulf Stream current at this location, but there certainly has been plenty of current. It'll be interesting to see how much stronger it is at the top.
I'm going to sit close and take a nice look at that coral upper right.
Upper right? Yeah, sure.
We haven't seen one for a while.
We're going to stop and take a closer look at this coral. Looks like one of the Bathy-Pathy type corals from here. There's also a small fish in front of the coral.
Try to get it near the front of your skids if you can, sir.
Yep.
So I guess there must be either a larger nodule or something underneath that coral that it's
there must
growing
be,
on.
yes. Must be.
Okay, go in video.
And a crinoid at the end of one of the branches of the coral.
It almost looks like the base is right there and it's on a nodule and maybe something has grown around the nodule. Scott, did you say something? I couldn't hear.
Yeah, sorry, Leslie, I was saying this looks like a pretty characteristic member of the genus Bathy-Pathy.
Great.
Continue down and we'll look at the, actually wait, there's a worm.
I think I see on the
We'll look at
branch,
the base
the
and
lower,
go back to the worm that he's about to talk about.
out of the screen above, one of the branches that was coming off
going up.
had a polychaete.
Another one of the worms, yeah, right there.
We often see those on the main axis, but you'll see it's a little bit of purple on that third branch from the bottom going up.
Oh yeah, good eye.
It's funny, we saw one of those earlier and we thought it was the black coral stem, and I don't remember who noticed it, but somebody noted that it was not the stem, it was a worm. So that's the second one.
This is an interesting and frequently observed association between these sorts of polychaetes. They're called scale worms of a particular species.
Going for full screen.
Bathy-Pathy black coral.
Copy. Watch leads. Besides looking at this coral, we're also waiting for the ship to catch up.
Great, roger that, pilot.
Maybe while we're sitting here, we could knock over one of those nodules to see if there are any serpulid worms, any of the flat nodules. If you could just peek under them.
Copy that, watch lead. Do you want to go full wide video?
The largest that you can handle.
So
Maybe the one to the left of the coral.
What am I looking at there?
Although that might damage the coral.
Yeah, that'd be. There's some others. Do you want me to go?
Bundle.
Yeah, maybe if you can just find a slightly larger one.
Okay.
You could motor a little bit.
Copy.
What is that?
Unless we can move forward. I was just pausing since you were mentioning the position. If we can move forward, let's keep doing that.
Yeah, we're still waiting.
Okay.
D2 is pretty far in front.
Okay.
You can zoom out, Roland. Thanks.
Little rat tail fish going by.
Another move after this one, co-pilot?
Yeah, maybe after the shift change. We'll just keep it here for now.
Copy. Copy, bridge. Move complete.
Okay. All right, we're going to do a pilot change real quick. Watch lead.
Having a change of pilots here, so.
Oh, we have a burrow. Maybe while we sit here, someone will come out.
Yep.